In this chapter, we're going to solve systems of equations. We're going to learn about 3 different methods on how to do that. In this first section, we're going to learn the geometric method, and that is by graphing. So let's look at our first system. Over here, again, we have the x and y axis. We're going to graph the following 2 equations on the system. We have x plus y equals 12 and minus x plus y equals 4. We're going to see what it means to have 2 lines graphed on one set of axes and to see what are the possible outcomes. What are the possibilities for 2 lines being graphed on the same set of axes? To graph this first equation, x plus y equals 12, probably the easiest method of doing that would just to use our t bar of values and find 2 ordered pairs that make this equation true. The easiest values I can choose are probably x equals 0, because if x is 0, y is 12. And I can let y equal 0 as well, and when y is equal to 0, I can easily see that then x is equal to 12. So I have the 2 ordered pairs, 0, 12, and 12, 0. Those 2 ordered pairs lie on my first line. Now I go up to my axis and I see that I need to get to 12. So what I'm going to do is label these here. Instead of 1, 2, 3, we'll label these 2, 4, 6, 8, 10. And then that would make 12 just about, let's move our x over just a bit here. Let's make that a 12. And then we're also going to do the same on the other axis. So this here is 12 down at the end. And again, this is our x-axis, so we'll add that there. Now, going up, we're going to do the same thing. We've got positive 2, 4, 6, 8, 10, and right here would be 12, so we'll just add that in. Now that we have that in mind, and again, of course, going down, those would be negative 2, 4, 6, 8, 10, and negative 12, and similarly to the left of the origin along the x-axis. So let's plot the points. 0, 12 would give me 0 here, and 12, let's do that in another color so we can see it a little clearer. That would be black. 0, 12. And then we have the other ordered pair, 12, 0, which is over 12. And there we have it. So now let's draw the line that connects those 2 points at 12, 0 and 0, 12. And we get a line that looks something like that. Now, one thing about this first method of solving these systems of equations is that we have to try to be as accurate as possible when doing our graphs, because we're actually looking for, if they intersect, we need to find out exactly where they intersect, because that intersection will then be the solution. Let's look at our second equation. This time we're going to graph minus x plus y is equal to 4 on the same set. So again, probably the easiest way, well, let's see. We could easily change this equation into slope-intercept form, y equals x plus 4. So what I did is I converted this first equation into simply y equals positive x plus 4. Now that it's in slope-intercept form, I can easily graph it. So y-intercept is equal to 4. That means here it is at 4. My slope happens to equal 1, since I have the coefficient of my x term is 1. So my rise over run is 1 over 1. So from 4 I go up 1 and over 1 for my second dot. And then again, just try to be as accurate as possible, because we're looking for the point. If they do cross, we need exactly, we need to know exactly where that is. So we'll go ahead and draw that line. So there we have it. Now, because the graph of these 2 equations is the intersection of these 2 lines, this one point here where they cross, or their intersection, is the one point that would make the first equation true and the second. In other words, it satisfies both equations. If it satisfies both equations, it's considered the solution to the system, or in this case, a solution to these two equations. Now, where does this cross? Well, it looks like it crosses at over 4 and up 8, so we'll say the solution to our system is the ordered pair 4, 8. Now let's just make a quick check to make sure that's true. Again, if this point lies on both lines, it makes both equations true. Is 4 plus 8 equal to 12? Yes, it is. And is negative 4 plus 8 equal to positive 4? It is indeed. So by that quick check, I can be assured that my graph is pretty much accurate. Again, do the best you can because you're looking for ordered pairs that make both these equations true. Let's see if there are other possibilities in graphing these equations. Let's look at our second equation here. We have 4x plus 2y equals 8, and we have negative 6x minus 3y is equal to 6. Let's see if there is another way besides just the lines crossing there. Is there another way that these two lines can lie on the plane together? Let's check. First of all, we're going to graph 4x plus 2y is equal to 8. Again, it seems to me that the easiest method for this particular problem would be, again, to find a couple ordered pairs and plot. So let's let x equal 0. When x is 0, we're left here with 2y is equal to 8, or y is equal to 4 here. Let's again get another ordered pair by letting y equal 0. If y is equal to 0, I get 4x is equal to 8, or x is equal to 4. So I get the two ordered pairs, 0, 4. So we'll use our regular markings here as 1, 2, 3, 4. So we'll go ahead and remind ourselves that we're changing the scale back to normal. And then y in this case, again, 1, 2, 3, 4. So 0, 4 is right here, and 4, 0 is right there. We'll connect the dots again. Here we go. And there we have the graph of our first line. Again, that's our first line, 4x plus 2y is equal to 8. Now I look at my second equation and I see that it's negative 6x minus 3y is equal to 6. Let's see what happens in this case. Again, xy. I'm going to choose a couple of points. I'm going to let x equal 0. When x is equal to 0, I see negative 3y equals 6, or y is equal to negative 2. If I let y equal 0, I have negative 6x equals 6, or x is equal to negative 1. So I'm going to plot the point 0, negative 2, which is right here. And the second point is negative 1, 0, which is right here. And then I'm going to connect the dots. When I connect the dots again, what happens this time is I notice that the lines do not intersect at all. In fact, if I were to draw it all the way out, I would call these particular lines parallel to each other. So if these are parallel, the lines have no point in common, we say that our system has no solution. So here we have no solution. So far, we have looked at two different ways that lines can lie in a plane together. Over here, they have one point in common. That's a solution. We call that a consistent system. Over here, there are no points in common. That's called an inconsistent system. Now, can we think of one other way that 2 points could lie on a plane together? First of all, we had again the two lines intersecting in one point, the two lines not intersecting at all, being parallel to each other. And now let's see if there is a third possibility. Let's graph the following. 3x minus 9y is equal to 18, and negative 4x plus 12y is equal to negative 24. So again, let's look and graph both equations here. In the top equation, if x is equal to 0, y is equal to negative 2. In the top equation again, if y is equal to 0, x is equal to 6. Let's plot those 2 points. 0, negative 2, There we have it. 6, 0, 1, 2, 3, 4, 5, 6. And there we go. Connect the dots. And we have the graph of our first equation. Now let's see what happens in our second equation. In our second equation, again, we're going to find a couple of ordered pairs that satisfy the equation. So here we go. We're going to let, first of all, x equal 0. If x equals 0, we get 12y equals negative 24, or in this case, y is equal to negative 2. Our second choice, we're going to let y equal 0, so negative 4x is equal to negative 24, so x is equal to positive 6. Now let's plot these 2 points on the same set of axes. We have 0, negative 2, and 6, 0. What does that mean? We got the same points. If I were to graph that, let's put it in another color so we can see. If I were to plot that here, what would I get? Now I'm going to draw this just a little bit off so you can see it, I hope. I'm going to put it right there. And hopefully what you can see, or what I want you to see, is the fact that the graph of both these equations happens to be the same line. That's the third way that 2 lines can line a plane together. If that does happen, because there are so many points in common, we would not be able to count them all. But we say this system has an infinite number of solutions. So, what are the 3 different ways we can have 2 lines line a plane? Well, the first way, remember, was 1 point of intersection. That means they just cross each other. Our second way over here is when they're parallel to each other, they have no solution. And our third way over here is that the lines have everything in common, or there are an infinite number of solutions. Keep your eyes out for these 3 different results as you graph your systems of equations.